Okay, hello everyone. Welcome to our Python for Coding Interviews overview workshop from ACM Hack. My name is Shravan. I'll be teaching this workshop. It'll last about an hour. We might go a little over an hour, but we're looking to cover most of the content in this workshop like within an hour. So we'll try to be out of here at 6. For the slides, here's a link to this slide deck. I think for this workshop, it would be nice to have this slide deck with you on your computer, because when we start doing actual problems, it'll be nice to reference previous slides that we talk about, because we're going to talk through a lot of Python concepts. Like I'll try to explain it as best as possible, but in case you need to refer to anything previously said, you can have that deck with you. So that's the link, python-interview-slides. And if you haven't already checked in to our membership portal, that's the code to check in. You'll earn like 10 points for attending this event. But I think most of you probably checked in before. But yeah, that's the code. It'll be on the side, bottom left of the screen during the whole workshop. Okay, so to cover today's agenda a bit, first I want to spend 5 or so minutes talking about what coding interviews actually are and what coding interviews try to assess from candidates. After that, we're going to spend a good chunk of our time going over Python, like the basic concepts of Python, like Python syntax, variables, data types, and different Python data structures like lists, strings, and like maps, all that kind of stuff. After that, we're going to spend 10 minutes talking about specifically lists in Python and how we can use lists in our coding interviews to like do problem solving, to write algorithms and all that. And then we're going to spend the rest of the workshop talking about strings in Python, because you can do really cool stuff with strings that'll make coding interview problems a lot easier. So we're going to spend the majority of this workshop on that portion. We're going to do three LeakCode problems in total in this workshop. They're all going to be string related, and they're going to happen in the fourth part of this workshop. So yeah, let's get to it. But before we start, I do want to spend a minute or two having people get to know the people you're next to, just because this is one of our earliest in-person workshops. So we know a lot of you probably don't know other members in ACM. So we want to take 1 or 2 minutes to like get to familiarize yourself a bit. I know a lot of people are in pairs, so this is going to be good to like get to know who you're sitting with. So we'll take like a minute to go through like what your names are, pronouns, major, year, college, and your favorite music genre. So we'll take like a minute or so, like get to know the people next to you. Yo, what's up? Alrighty, awesome. I hope you got to meet the people next to you. For those of you coming in, if there's no room here, you can feel free to grab a seat in the back, or you can also pull up chairs. Yeah, that'd be good. To introduce myself really quick, I'll go through this. My name is Shravan, pronouns he, him, his. I'm a computer science major, 3rd year from 6th College, and favorite music genre probably hip hop. All right, let's talk about coding interviews. So to explain coding interviews a bit, all they are basically a portion of the hiring process for technical internships and new grad roles for companies. So whenever you apply to a job, there's like some kind of interview process if it's like any type of competent job. And usually interview processes will assess different things. And coding interviews are one of the interview types in when you're interviewing for companies for technical roles. They're most common in like software engineering interviews. So interviews where you'll be doing a lot of coding, or like jobs where you're doing a lot of coding. You're going to be having a lot of this kind of interviews. Generally, they last 45 minutes to an hour. And generally, when you're interviewed, when you're in a coding interview for a company, you'll have at least one engineer interviewing you. So they do have technical background when they are assessing your coding skills. Sometimes you will have more than one engineer, like a kind of panel where they're all kind of assessing you. I've had interviews before with like 3 or 4 engineers like at one interview. Um, Generally, these questions or these interviews are meant to assess your problem solving and coding skills by asking you a problem that can be implemented via code to solve. So generally, a question would be like, oh, given a list of integers or like an array of integers, like find all integers that sum to a particular value. Like a very like kind of straightforward, sometimes not very straightforward question, but a question that can be implemented via code with an algorithm using a programming language. And like I mentioned, they assess these primarily 5 skills, which I'll talk about in a couple slides. But that's the general gist of coding interviews. So I know many of you are going to try and apply to like software engineering internships or like technical internships in general. To highlight kind of what you can expect from an interview process. Generally for non-software or like non-technical companies, there'll be like 0 to 2 coding interviews. So sometimes you might not have any coding interviews. You might have technical interviews where they'll ask you like computer science questions or like data science questions, but you will not necessarily be doing like actual code or like running code. But for some non-software companies, you might have a couple of coding interviews. So non-software companies would be like State Farm, Prudential, like the companies whose like flagship product isn't like a tech product. Would be like a non-software company. For software companies, you can expect at least 1 coding interview for every software company you apply to or you interview with. Examples like Google, Robinhood, Stripe, NVIDIA, like some of the bigger name companies like from the Bay or from Seattle. You're going to be having at least 1 coding interview, sometimes up to 4. And for the like the big finance, or like big fintech companies or like the quantitative trading firms, like generally the companies that like pay the highest, they'll have like the highest bar for coding interviews. So you might have like up to 5 coding interviews for companies like Citadel, 2 Sigma, and those kind of companies. If you're not familiar with these company names, that's totally fine. But like generally, like those finance companies might have higher levels of interviewing. So clearly, preparation for coding interviews is important because worst case, you don't have to do anything. But in the average case, you might have like 2 or 3 interviews for like every company you're interviewing with. So definitely, it's good to have coding interview prep. So just to give an example, this is a company called Stripe. They're like a predominantly like tech company from the Bay. And their process is like 5 stages long, but they do have like 4 coding interviews in this process. Like if you apply for like an internship or a new grad job, you would realistically have 4 to 5 interviews, one being like a hacker rank, which is just a coding challenge. It's not necessarily like a synchronous interview you have. It's like it's an exercise you have to do like asynchronously. And if you pass that exercise, then you would move on to the next steps. They would also have a team screen, which is just like a technical phone interview. It would be like 1 45-minute long interview. Their on-site would be like a couple interviews. So for interns, it would be like 2 interviews. For new grads, it would be 3. And then a manager chat, which might also have some coding if your manager is like trying to assess your coding skills. So anywhere from like 4 to 5 coding interviews you might have in one process with one company. So this is probably on the higher end of interviews. Most companies might have like 1 or 2, maybe 3 coding interviews, but this is something you could realistically expect. This is what Stripe was doing this year for their internship and new grad roles. Right, so what do coding interviews actually assess? These are mainly the 5 things that coding interviews assess. And when you walk into a coding interview, you want to make sure you're demonstrating all these 5 things like as much as possible. So what most of you might know would be data structures and algorithms, right? So like on what data structures do you know and how well can you write algorithms and use other algorithms? So data structures would be things like array lists, arrays, binary trees, like linked lists, those kind of structures. Whereas algorithms might be like merge sort, binary search, or things maybe algorithms you're writing yourself. Maybe things like depth first search, all that kind of stuff. But I did want to highlight the last 3, which might not be as obvious as the other skills. The first one being coding ability. So like in these coding interviews, you want to highlight how good you are as a coder. So what does that mean? That really means like how good is the quality of the code you're writing? Like do you have variable names that make sense, right? Are you using like int n equals 5 or like are you using like int count equals 5? Like are you writing descriptive variable names? Are you writing functions that are clear in what they do? Are you like having comments all over your code, or is your code very easy to understand without comments? Like these are all things like that interviewers are looking for when you write code in the interview, because that's realistically what you would be doing in the job. Like if you're writing good code in your job, then you're a good performer, like you're a good engineer. So that's something to pay attention to. Problem solving also very important. Like, how do you take a problem that's given to you, break it down into a series of like digestible things that you need to write an algorithm for, and then ultimately come up with an algorithm and implement the code for it. Like, that is a very important skill to have, like even in the day-to-day job. But in the interview, they do assess your problem solving skill a lot with like how you try to handle like difficult problems. Lastly, communication. How well are you talking to your interviewer? How well are you like raising concerns you have, or how well are you like clearing up maybe ambiguities in the question? Like, let's say you're given an array of integers or something, like, are you clarifying like, hey, can I expect these to be like non-negative, or are they all like, can they be any integer? Like, can they be positive? That kind of stuff. Is this array sorted? All that kind of stuff. You want to be being as clear in your communication as possible in these interviews. And we're going to try to go over these when we're doing our problems later on. So naturally, we want to choose a programming language for a coding interview that allows us to highlight these skills as much as possible. So there's tons of coding languages we can use. We can use C++, Java, Python, JavaScript, Go, like all kinds of programming languages. But we're really going to make the case for why Python should be the one that you use for these coding interviews. So I want to highlight 4 reasons why we want to recommend Python as like one of the best programming languages to use for coding interviews, mainly because it's syntax simplicity. Like, you can see Python doesn't have like, when we go into Python, you will see like there's not very many brackets, or there's not very many like parentheses. Like, generally there's like less symbols you need to write like when you're coding. So less symbols means less room for error because you are simply typing less. And it's just easier to understand when you're coding it. There's also a lot of built-in data structures like lists, tuples, and dicts that we'll go into later that really allow you to write some pretty clean code in Python. Whereas in like Java, it might take multiple lines to do the same thing. Also, dynamic typing means you don't have to be strict in your typing of variables, because variables can hold different types at the same time. Like, you can have a string and make it an int later, and that's totally like legal. And we'll go over examples of that later. And lastly, there's a lot of Pythonic features, which are things that are like specific for Python's like programming language that don't exist in other languages, like list comprehension, which we'll spend a bit of time on talking about. And list comprehension is very cool. It's a very cool Python feature. So we'll go over that later. Right. So now let's go over a quick Python overview for the next like 15 minutes. So we're going to talk about things like types, variables, like loops, functions, just like the basics. Let me get some water real quick. All right, and if anyone has any questions like along the way, feel free to like raise your hand or anything. All right, so let's start with the basics. Python variables. So in Python, you can see variable assignment is very simple. You just have the variable name equals the value. So like, for example, we have song equals what's poppin'. And if you print song, it just prints what's popping. You don't need to specify a type or like have semicolons or anything. It's simply the variable name equals the value. So we can have strings. So string, like song would be a string. Num listens would be an int. And like we say on the next line here, you can see we assign song equal to 15, even though it was a string. Now we're setting it to an int. It is legal to do that because Python does have dynamic typing. So song will print 15 here. So that's like the basics of variable assignment. And I am going to go kind of fast through these slides. There's no worries at all if you like don't catch everything. When we actually go to coding, that's when you're going to learn the most of like how to use Python. So this is more of a reference like for you going back, or like for you getting a refresher if you already know Python. All right, let's talk about data types. So at the top, we have a lot of very basic data types that Python has. So firstly would be an int. So like attendance is equals 50, that would be an int. We can also have floats, which are just decimal numbers, like GPA equals 1.9. I'm sorry to anyone who has that. It's okay though. So we also have Booleans like likes pineapple on pizza. That's me. I don't like pineapple on pizza. I know there's some people here who do, so that's okay. But also, so we have Booleans. Note the capital in the Boolean, false. That's not a typo. Python Booleans are capitalized. I'm not too sure why, but they are. That's just be like a feature of the language. If you type false with the lowercase, the Python interpreter will freak out and not know what to do. So make sure you're uppercasing those. We also have strings. We have lists. So for people who are familiar with Java, this is going to be your array and array lists. There's no like distinction between arrays and array lists. It's just a list of ordered items, which we'll talk about later. None of these are actual courses, but that would be cool if they were. And we also have something called a dict. So we'll talk about this a little bit later, but a dictionary is simply a mapping from one value to another. So for example, like here, you see there's brackets and like a kind of dictionary thing going here where we have like a key, which is hack school, and a value, which is 15. So here you can see it's a map of like events to the attendance count. So you can see like Essence of Back Engineering might have 10, Hackmo might have 20. So dictionaries are the equivalent of like Java hash maps or like hash maps in general. These are very important for coding interviews. We're going to go through a problem later on that uses dictionaries, and we'll walk through how we can use those. But yeah, lists and dictionaries and strings, very, very important in coding interviews, and we're going to spend a majority of today focusing on those. All right, so let's get to logic a bit. So for if statements, pretty like standard syntax. Note that there's no parentheses when you have your condition, and note the lack of brackets. Instead, we have colons and we have indentation. I will note indentation is actually needed here. Python does care about indentation. So because there are no brackets, Python doesn't know where blocks will start and end unless you indent them. So make sure you're indenting the print statements here or when you're doing if statements. A lot of bugs will come up if things aren't indented, or like sometimes the program won't even run because it would think there's like an empty block or something. So here, note also the elif. For else if, in many programming languages, it's else if, but here it's combined into elif. That's how Python does it. So no, yeah, if we have if, else if, and else syntax here. Let's talk about if statements some more. For negating logic, we can use the not keyword to flip it. So in many languages, you have the exclamation mark to flip logic, but here we have the not keyword. So if not ramen in favorite foods, what are you doing? Print bruh. So that's why we have a list. So like also note the in keyword. If we want to see if an element is in a list, we could do that by doing like if something in and then the data structure. So when we're doing dictionaries, we can also do that. Like if hack school in dictionary, then print something. But here, that's how we do, like, if something is in a data structure, then that's how we do that. And also note, like here, it kind of reads like English. If you read the if statement, like if not ramen in favorite foods, it's like kind of grammatically off, but like it's pretty close to English compared to like other languages out there, which is why Python's pretty cool. Because if you speak English, then you already know some of Python. So. Okay, let's talk about loops now. So with loops, we have the standard for loop. We also have while loops. For loops, the syntax is a little different than most programming languages. You can see also no parentheses except for in the range. So here for I in range 1 through 10, that is going to go through all the values from start to end, inclusive and then exclusive. So this list or this for loop would go from 1 to 9 and then stop, because the last value would be exclusive, so it would exclude that value. So here, this for loop up here would sum the values between 1 and 9, and then print that sum. So just note the use of colons again, indentation, no brackets, and the range keyword, which is going to be like the start and end to the for loop. For our while loop, we have like pretty standard syntax. It's just lacking the parentheses again. We have a condition. While the condition is true, we can do any kind of operation, and that's going to do that. We also have break and continue statements in Python as well. I know a lot of other languages have like break and continue for like if you want to break out of a loop. Python also has that, though that's not shown here. Okay, so let's look at a couple ways of iterating, because there's some interesting ways of iterating through objects or iterating through like numbers. First thing I want to highlight is the the short syntax at the top, like for I in range length s. This is going to iterate through from 0 to length of s minus 1, even though we don't specify 0. It's going to start at 0 by default and go until the value specified exclusive, so it would go to 1 minus that. So this is going to be a very common way of iterating through lists or iterating through strings. But even more common is the one under that. So we notice that we don't really need the index in the first loop because all we're using the index for is to access the character. Instead, what we could just do is for C in S, print C. This is kind of like your for each loop in other languages. This is going to be how you like iterate through the characters without needing the index. And if you actually do need both, then you can use the enumerate keyword to do I comma C in enumerate S. This will print the character at index and then the index. And it's important to note here, you see there's some kind of casting going on here. Like, what is this? In Python, one thing to note is when you do string concatenation, and we'll talk about this a lot more in our string section, everything that you concatenate with in strings needs to be a string. So the C is a string, this is a string, but then I is an integer, so we need to cast it to a string. And that's gonna, we'll have like an example on that soon, but that's just something to note here. Lastly, for loops, I did want to cover, you can actually skip elements. Instead of doing like I++, you could do I plus equals 2, just by specifying the third parameter. So you can have 0, length s2, and in the string, it would print like every other letter, like starting from 0. And here we don't need the 0. It could just be length s comma 2, and that should work. Yeah. Cool. Oh yes, and note that step can also be negative. So it doesn't always need to be a positive increment. It can be a negative as well. So I have a question for you all. Given what we learned about loops, how can we print a string in reverse using loops? So here's 4 kind of examples we have here. You can take some time and read through them. We'll take 30 seconds to come up with like which answer we want it to be, and I'll ask people like raise their hands and like see what people think, like what answer to do. So we'll take like 30 seconds to think about an answer here. Okay, any guesses here? Which one would be how we print strings in reverse? Anyone? Yes, Garrett. Yes, it is D. So can you explain to me why it's D? Right. So that's the one thing to note. Good job, Garrett. When we're iterating through a string backwards, we want to make sure we print the 0th index, and like we want to make sure we print that, right? So if we do 0 instead of -1 for the second parameter, then we would omit the 0th index because that's being excluded. So D is the right answer here. All right. Let's talk a little bit more about functions. We're almost done with the Python overview. But functions, pretty standard with other languages. Just note the syntax here. We have def as like defining a function. The function name, so binary underscore search, and then we have parameters. And note that the parameters don't need to have types. They just have any types passed in. So there could be errors if the user of this function passes in different values. So that's like the one downside to dynamic typing, is that like if someone tries to use your binary search function and they pass in like types they shouldn't be, then Python won't know that until runtime. When you run the Python code, it'll be like, yo, like I don't know what this means. Like a string might, or like an integer might not have a length if you pass an int into array. So this is just binary search, but just note how like, oops, I don't know what that was, but yeah, just note the syntax of defining a function and note the indentation here while we have nested loops, right? Because you see like everything's being indented, right? With the while loop, with the if statement, with the else if statement. That indentation is necessary in Python. So. Cool. Last couple slides for overview. Here's going to be dictionaries and maps. So this is going to be your hash map in Java. If you all know, if whoever knows what a hash map is, that's what a hash map is. It's basically just a mapping of keys to values. So like the example earlier, we have like hack school to 15, like string to int mapping. In Python, since we're dynamically typed, we can have different types, different mapping types. So we can have an int to a string in the same map as a string to an int. That's legal. In Java, you would need to like specify the type, and everything has to adhere to the same type. To add a mapping, we would just use an indexing here, like the bracket syntax with Python for coding interviews equals 5. We have more than 5 people here, which is awesome. But yeah, that's how you add a mapping. And for checking if a mapping exists, we would do like the if in syntax, where like if hack school in event attendances, then we can increment that value by retrieving it with the hack school like bracket syntax plus equals 10. Otherwise, we can just set it to 10, because if you try to like maybe modify a value, like do plus equals 10 on a key that doesn't exist. So let's say we just did event attendances hack school plus equals 10, and hack school wasn't in this map, then an error would throw. So like here an error wouldn't throw because we're assigning a value, but since we're incrementing a value, it would error out because the default value isn't defined, right? If hack school wasn't in this map, then plus equals 10 wouldn't know what to increment from. It doesn't increment from 0 by default or anything. So be careful you're setting your default cases first. Lastly, I want to cover tuples for the overview. Tuples are a Python specific data structure, so this doesn't exist in other languages like with the same name. But basically they are an immutable sequence of items. So it's basically like a list, but tuples you cannot edit when you create them. So let's say we have an RGB tuple with like 255, 0, 255. So this is like how RGB is kind of like what the colors on your computer screen, like this is how they're kind of encoded. So you can print that, but we can't change the value at index 0 to 1. You see that'll throw a type error because tuples are meant to be immutable. And we can have tuples as keys for dictionaries, like you see here. If we have color counts as a dictionary, this is an empty dictionary, then we could set the RGB as the key and equal to 1. And this will print the RGB value here as a tuple in a key mapped to 1. And we cannot do this with lists. We can't use lists as the keys because lists can be changed, which causes problems for when you try to like access a list. So this is going to be a very important tactic for our last LeakCode problem that we go over, because Python makes it really easy to like encode lists into tuples so that we can map lists to different values like an integer. Cool. That was the Python overview. So that's like the very fundamentals of the Python language. We're going to dive into lists now, and then we're going to dive into strings. And strings are going to be where our we're going to do our hands-on kind of LeakCoding thing. So any questions on Python overview so far? Okay, cool. All right, so let's go to lists. So we covered a bunch of data structures at first, but lists are going to be one of the most used data structures in any interview. Like there's a very high chance you'll be using some kind of list in an interview question if you're doing Python, because lists are just very flexible. It's just an ordered collection of elements, and like I mentioned earlier, it's just your array or array list. So here we can have courses. We can define like a list literal, so like we can define values in it already. Like current courses, we can also define an empty list, and we can also define a list of like type integer. But again, since Python's dynamically typed, we can mix integers and strings on the same list. I don't have an example here, but theoretically, like we can make one of these a string and Python wouldn't complain. So that's how we define lists though. Some basic list operations. We can add elements to a list and remove elements to a list with append or remove. So we can add CSE12L or CSE15 to our list with append, and we can remove them with remove. You can also get an element by its index with like standard indexing, like arrays. Like you can get the 0th index. I also did want to note here, you can index negatively in the list as well. So if you want to get the last element in the list, you can do current courses of -1. That also does work. And you'll notice, like, for those of you who know what stacks and queues are, we can use Python lists as stacks and queues by modifying or by accessing different like parts of the list. Cool. So this will be a quick exercise. Just to go over pop. Pop is another method that lists have. Basically, it just removes elements in a list by the index. So if we have like pop and then it's empty, it'll just return the last element. It'll remove and return the last element. So for last test score would be 95 if we pop it. For first test score, if we pop 0, that'll return the first one. And then if we do another pop, does anyone know what value would be returned for the first what value with that pop 0? Any guesses? Yeah. Correct, yeah. So 98 would be the first element in the list after we popped the 86, so that would be popped. Then what if we pop 1 after we pop the 98? What gets returned? Any guesses? Yeah. Yes, 92, because our list would be 73, 92, 91. So we would return the first index, which would be like the second element because we index by 0. Good answers. And then, yeah, lastly, what this will print, it would just print, I guess, what would it print? Any guesses? Any last guesses? What would be the list that's printed at the end? Yeah. Right, correct. Good job. Yeah, because all the other ones were removing. So. Cool. Okay, so that's how we do lists, elements, adding and removing. Now I want to cover a very important topic called list comprehension that's specific to Python. It's not, you can't really find this in many other languages. This is what makes Python like super cool and awesome and easy to use. So here, what is list comprehension? Basically, list comprehension, you can create lists based off of like loops. So what this means, like, let's say we want to create an array of numbers from 1 to 10 that store all the elements of 1 to 10. Here with the syntax, you can see we can do nums equals I for I in range 1 through 11. And remember the exclusive, so that would print 1 to 10. So with list comprehension, we can have the brackets like for the list, and then write a kind of for loop kind of syntax that has like the element that you want to have in the first character. So it would be like I for I in range 11. So I would be the element in that list, and it would be I would iterate from 1 through 11. So it would be 1 through 10. So we should print 1, 2, 3, 4, 5, 6, 7, 8, 10. Likewise, we can do the in syntax that I talked about earlier to do like more nums equals num plus 5 for num in nums. So it would take every number in the array of nums, add 5 to it, and set that in more nums. So this would print 6 through 15. Lastly, one cool tip is if you're not using the iterator like variable in the loop, then you don't actually need to specify. You could just have an underscore. So here we want to initialize an array of all zeros. So it's not actually dependent on the value of I or the value of the thing we're using. So you can just use an underscore, and that'll save space, like when you're coding. So you see the first example, it actually uses I because it goes from 1 to 10, but these are all going to be constant values. All we care about is the number of times it's being written. So that'll return 5 zeros. Cool. So let's take 1 or 2 minutes to go over this question. Given what we know about list comprehension, how can we generate a 2D list of like a 2D list, so a list of lists, where there's 5 rows and 3 columns? So this would be an example of what we want to generate. So let's say we want to do this with list comprehension. How would we do this? And this time I want you to talk with the people at your table and try to come up with an answer. And we'll take like a minute to do that. So say hi to the person next to you and discuss, yeah. Yeah. Oh, that is just like list multiplication. So that also works. You can do that here. It's not called list comprehension, but if you want to do a similar thing where you have like 5 zeros in a list, you could do bracket 0 times 5, and that would work. Huh? That would just be an empty list. Yeah. Okay, cool. Any guesses on which assignment we would want to use and why we would want to use it? Any takers? Yeah. Yeah, correct. Awesome. So the reason why A doesn't work is because remember with the syntax, we want to have the for loop inside the brackets because that's what we're building the list inside of the list. And then once that's done, it's created. That's kind of how I think of it. So we want to be careful because A doesn't do that. It does it outside the brackets. So that's going to be a syntax error. And the other two ones would create, well, D or C would be a syntax error again, and D would create a list of 3 by 5 instead of 5 by 3 because we generate the 5 elements first and then do that 3 times. That would be a list of 3 by 5. So yes, the answer is B. Very good. Cool. So that was lists. That's going to be like the bread and butter of what you need to know for lists and coding interviews. Just to give like an aside, I've had to do this like pretty frequently in interviews, like generating a list or a matrix. Like let's say if you need to do like some kind of like dynamic programming, those of you who know what dynamic programming is, or you need to like create a matrix and like iterate through that matrix and do some kind of input output stuff with that, then generating a matrix like that is important. So this is good to know. Cool. All right. Any questions on lists before we go to strings? And here's where we're going to start doing some coding here. Yeah, if we'll take like a 1 or 2 minute break actually. If you all need to like get water, use the restroom, stretch. I think we'll see. We'll come back at like 5:42. It's 5:40 right now, so take like a 2 minute break. How you guys doing? Huh? Awesome. What were you guys' names? Migo? Miko. Awesome. Got you. What was it? Huh? Matthew? Nice to meet you all. I'm from Charlotte. Yeah. What's up? Thanks for coming. What's up, Connor, right? Awesome. Thanks for coming. Yeah, thanks. Appreciate it. Yeah. Yeah, nice to see you again. Yeah, good, man. How you doing? Yeah, what's up? Yeah. Uh-huh. Yeah, so everything in Python is an object actually, but Python abstracts away the whole memory management for you. So that's just like a thing built into Python where like, yeah, if you print any of these 2D lists or 1D lists, like it would print the actual list. So you won't actually have, like in Java, it defaults to printing the address and you can toString it. In Python, it's kind of the opposite where it defaults to toString and you can print the address if you want to. I'm not too sure how to do that, but there should be ways of doing that if you want to print the actual like address. Yeah. Yeah. No, yeah, yeah. So there are like not built in. If you want, I think there's something called Cthon actually, which is like it's like a mix of C and Python where you actually can do that. Yeah, yeah, it's crazy. So Python, yeah, you don't need to worry about memory management at all. If you want to like create classes or objects or anything, like yeah. I recommend if C and Python sounds interesting to you, Golang is okay, but yeah, that's true. Yeah, Golang is a language that it's very similar to C and Python where you can do memory management, but it's like Python syntax. and it's like used, it's like gaining traction in like the industry. So I just like an interesting language. Yeah, so like Google wrote the language in like 2015 or 2014 or something, and yes, it's less compiler strict than C++, but definitely more strict than Python. Like, yeah, yeah, it's like a mix. Alrighty, y'all. Let's get to some Python strings over here. Okay, so let's start from the basics. So strings, like we talked about earlier, you can just define them like that. There is string concatenation. It's just with the plus operator. So if we want to concatenate these two strings, then we could do fizz plus buzz and get fizz buzz as one word like here. Alternatively, we can add our own string literals into print statements or into variables, where we could be fizz plus space plus buzz, and that would work. Alternatively, we can be extra spicy and multiply our strings together, and we can get multiply a string by an integer and get it replicated 3 times. So print fizz fizz fizz. And no, you cannot multiply 2 strings together. That's invalid. But you can multiply a string and an integer, and that would duplicate the string that many times. So for concatenation, this must be done on 2 strings together. So here, let's say we define an integer called count. That's 5. We cannot do the first line because we're concatenating a string and a number or integer, and that would result in an error. So like I mentioned earlier, I brought this up earlier, but you would need to cast this to a string, and you can use that with str. That can cast it to a string. So this is actually good to remember because when you're debugging Python, you're not going to be using a debugger. You're going to be using print statements. I mean, like I just use print statements because they're easy, but you should use a debugger. But if you are using print statements and need to like print the value of something, then you would need to cast it to a string. Okay, so just like a super quick question here. Let's say we have these 3 variables, source, dest, and data. What would print out of this print statement? Let's take like 15 seconds in your groups to discuss, and then we'll see what happens here. So. Alrighty, any takers? What would the above print? Anyone? Yes, Garrett. Yes, it would be an error. Very good, because we can print the source and dest, but when we try to print data, since it's a list and not a string, that would be an error. So instead, what we would need to do is something like this, where we cast data to a string, and that would print what we actually would want it to print, like that list. Cool. Okay, let's talk about string indexing. So string indexing is very similar to array or list indexing. So here, if we want to get the character, the first character in a string, we could use the index 0. So that would print 5 right here. So I know in Java you have to do like character at or something like that. And instead of that, we could be cool and just use indices. So we can also do something called slicing, which is interesting. Here we can actually get a substring out of a string using the colon syntax. So here we can go from 0 to 2 exclusive, which means it prints the first 0th and 1th character in the string. So this would print 50. 3 to 7 would print cent. because we start at index 3, which would be the C. And we would do 3, 4, 5, 6. So that would be sent. And note that even though 7 is not a valid index in the string because the last index would be 6, this still works because it assumes it's exclusive already, so it won't actually access element 7. If we want to skip elements like we did with the array or with for loops, we can do every 2 characters instead of every character. So that would print CN. Here, if we want to just go from one character, like a start, to the end, we can just omit the last, omit the second number and just do 3 colon, and that would also print sent because it just goes to the end. And just to note, we can do that with the other way around too. If we want to go from the start up to an element, we could do colon, like colon 2 would result in 50. If we do like print favorite wrapper of colon 2. Yeah. Like with lists, we can access elements in the negative order. So we could do -1 and that would return T. And -4 to the end, this is a little kooky, but this would also print sent because here I can't reach that high, but T would be -1, N would be -2, E would be -3, C would be -4. So -4 to the N would print sent. That was, I skipped a slide. There we go. So last slide on strings, or actually last slide for now on strings. Strings are immutable, like you might have learned in Java. So you cannot change a character at an index in these strings. So let's say we have a string. My name is ACM Hack, and I love to hack. Very cool. We cannot change all the A's to E's. So you can see here, this loop is basically iterating and checking if it's an A and setting it to E. We cannot do that because strings are immutable in Python, so we can't change the actual internals of the string, like change individual characters. So that's a note on immutability. Okay, so let's get to our first LeakCode question. So LeakCode, for those of you who might not know what LeakCode is, it's basically a coding interview platform, a website where you can just practice coding interview questions. This is going to be our first one. We're going to do this together, and we're going to have one shortly after where we're going to have you all do for like 10 minutes. And then we're going to do a more challenging one near the end together. That's kind of the agenda for the rest of the workshop. So let's have a look at this question. Split a string into balanced strings. So I'll give people some time to pull up the link here. But here is the link. I have an extension here that like hides the code, so I can set like a stopwatch and everything. That's just like, you probably won't see that. I have the code there. That's not ideal. Let me go to Python. Don't worry about this. Let's just not, you don't see that. There we go. Yeah, we have a fresh slate here with no code previously written. Okay, so yeah, I didn't delete the code. That's fine. We're gonna walk through this together, so that's totally fine. Okay, so what does this problem say? It might be hard to read. Let me zoom in. Hopefully you all have this pulled up on your computer too. Yes, so we're given this question. Split a string into balanced strings. Balanced strings are those that have an equal quantity of L and R characters. Given a balanced string S, split it into the maximum amount of balanced strings and return the maximum amount of balanced strings. So what I like to do when I get a coding interview question is first look at an example just to try to understand, like see if I know what the question is asking me. So here we're given an input S. So we know that it's a balanced string, which means it only consists of L's and R's, and it has an equal number of L's and R's. That's what we're given. And we want to split it into balanced strings. So here we have LR or RL, we have this like this string here. And we have the output as 4 because it can be split into RL, right? That's a balanced string because there's one R, one L. We can also do RRLL, right? And then we can do RL and then RL. So we could do those 4, and that would result in a output of 4 because there's 4 of those balance string in this larger balance string. So yeah, that makes sense. Remember, we want to return the maximum amount of balance strings. Secondly, here we have another example. We have L or R and then 4 L's. So here you see, here's one balance string, RL, right? And then we can also have this balance string, LLL, RRR, and then this balance string, LR, right? So that's going to be 3. And then lastly, this one, you can see it has 4, or just 1 because it's 4 L's and 4 R's. And then here we have 2 because we have RL. And then we have this larger string, which is 4 R's and 4 L's, but they aren't contiguous. Like they aren't next to each other. So it could be like not all the L's are next to all the R's. Like they're kind of mixed in between. Cool. So hopefully that makes sense. So with LeakCode, they do provide constraints, which I always like to read. So we can assume that the string's maximum length is 1,000 and that it's a balanced string and that every character is either an L or an R. So we know that every string we get has like either a capital L or a capital R. Okay, so how do we solve this problem? Like, where do we start? So we can see that this is a string problem, right? Like we're given a string, we need to count stuff in the string, so we need to somehow iterate through the string, right? But what are we trying to find? And I'm going to walk through this and talk out loud, explain my thought process. And then you'll have a turn to do that for the next question. So here we want to return the maximum amount of balanced strings, right? And every string that's balanced is going to be like kind of next to each other, right? So we know that a balanced string is going to have all the characters in a chunk, right? So with RL or LLL, RRR, LR. And we know that the entire string given to us is already balanced, which means that there's going to be at least one string inside that string that's balanced, right? So what we can do is, since we want the maximum number of balanced strings, we can iterate through this array. And let's say when we see an R, we know we want to see another L so that when we match those two, it can increment our count. Because remember, we want the maximum number of balanced strings. So even if we see just one R and one L, we don't want to have to wait and find other R's and L's because that would result in a balanced string. And we want to increment that because it would be a small balanced string, which means we can find more balanced strings later on, which would maximize our amount of balanced strings. So hopefully that makes sense. But the idea is that we want to, every time we see an R, let's increment a counter we have. And every time we see an L, let's decrement that counter. And if that counter is 0 after our iteration, then we know we have the same number of R's and L's. Because let's say we increment when we see R, we decrement when we see L, and we're at 0 again, then we know that we've seen an equal number of R's and L's, right? And we're going to do that across the entire array. So like, let's say here for this example, let's say I increment a counter when I start at R, right? When I see an R, and I decrement when I see an L. Here, let's say, okay, I'm going to start at the front of my array. So I'm just going to do a simple for loop through this string. Okay, so let me check this current element. Is it an R or an L? It's an R, so I'm going to increment let's call it a diff variable, like a difference. So we're going to see like the difference between R's and L's, and we're going to increment that. Okay, let's move on. So before moving on, we want to see, okay, is our diff 0? If our diff is 0, then we have a balanced string, and we're going to increment. But where diff is not 0 here because we just found an R and we haven't found an L after it. So that's going to be, our diff would be 1. So then when we encounter this L, when we go to our next iteration, then we subtract our diff, and that will become 0, which means we have an equal number of R's and L's. And that means that we have a balanced string, and we're going to add that to our count. And then we could just move on to the next string. So to go through this really quickly, this would increment to 1, this would increment to 2, this would decrement back to 1, this would decrement back to 0. So this means that this is a balanced string because we go 1, 2, 1, 0, right? And then for here, for this part, we go 1 0 1 0, right? So that's going to make sure that we get 2 balanced strings out of here, because like what I just highlighted is 1 balanced string, but we can split it into 2 balanced strings because it's just increment, decrement, increment, decrement, and we want the maximum number of balanced strings. So which is why we're counting this as 2 and not 1. So that was a lot of like very high like context or conceptual stuff. Let's like write some some code for this. In an actual interview, you would write some pseudocode first before you write code, just so that your ideas are down. So let me actually do that, just so that we're doing good practice here. So for pseudocode, in Python, you use hashtag as comments. So in most languages, it's this, but this doesn't work. You want to use a single pound symbol. So what we're going to do is iterate through the string, and then before this, we're gonna initialize a diff and count variables. So diff is going to be our difference between L's and R's. Count is going to be the total number of balanced strings. So let's actually name this to num balanced strings instead. Num balanced strings. You guys don't need to write this code if you don't want to. This is going to be pseudocode. So we're going to iterate through the string, and here, if we encounter an R, increment diff, otherwise diff, and then here, if diff is 0, increment count, and just return count. So that's going to be this algorithm here. So let's write this in Python now, but that's going to be the general pseudocode for this problem. So let's do this in Python. So this is where we're going to learn our Python coding skills. So here, let's do diff as 0, right? So we're going to initialize a variable called diff 0. We're going to initialize num balanced strings as 0, right? So that's going to be our first 2 elements. So then now for our code, remember, how do we do iterating through a string? We can do for C in S, right, to get the character. And then what we could do is if C is equal to R, then colon enter. You see how it automatically tabs it for us. We can do diff plus equals 1. Otherwise, we know that diff has to be minus equals 1. And one thing I will note, which I forgot to note earlier, is there is no plus plus and minus minus in Python. I don't know the reasoning why, but there's probably a reasoning for it. So you will have to do plus equals 1 and minus equals 1 instead of plus plus minus minus. So here we have that. And then what we can do is if diff is 0 after we've incremented or decremented, then count, or sorry, num balanced strings plus equals 1, and then return num balanced strings at the end. So here we have a loop with some if statements, some incrementing, and returning the num balanced strings. Okay, so I'll give some time for you to catch up here. But yeah, here we have our pseudocode down here. It's okay if when you're coding, it's all messy with comments and like comments in between code. What I like to do in interviews is comment a lot and like have like a section where I'm like writing out my my design process and then write the code later. And if the comments are there, it's okay. So let's run this code. If you have a LeakCode account, you should be able to run this. So you see that we do get 4 as our output. And then we can submit this code and make sure we're checking it on all the possible inputs. You see here, we got our algorithm to work with 96% runtime, which is really good. So that's how we do the first problem. Cool. Any questions on any of the syntax here? Cool. All right, so that was a nice refresher on Python. So yeah, I know it's already 6. So this might take, I'd say like 20 to 25 more minutes. So if any of you have to leave, that's totally fine. Because we're going to be doing just LeakCode problems from now. So most of the concepts has been covered. We're going to do one quick concept on ASCII. But then after that, it's just going to be questions. So if any of you have to leave, that's totally fine. But this might run until like 620, 625. Cool. Okay, so let's cover our last concept here. We're going to talk about ASCII. So what is ASCII? Some of you might have heard of ASCII in your 8A, 8B class or 11 or somewhere else. But ASCII is basically the idea that every character in any letter or any character in a language can be mapped to an integer, because that's what computers understand. Computers, they can only understand binary. So we need to map a character or an emoji or anything like that into a ASCII value. And ASCII value will be an integer, and that integer can be converted into binary. Yeah, so for example, A maps to 65. This is just, you don't need to memorize this or anything. That's just how ASCII works. The letter capital A maps to 65. B will go to 66, C 67, lowercase a is 97, lowercase b is 98. You might be wondering, why is the difference between lowercase a and capital A not 26? It's because there's a couple other characters in between, like periods and colons and stuff like that, in between the lowercase and uppercase. So that's what ASCII is. So if we want to get the ASCII values in Python, we can use something called ORD. So ORD is yes, he's a very famous professor at the school, but it's also a Python function. So ORD basically just returns the ASCII value of a character. So A would map to 65, B 66, the dot would be 46, A would be 97. That's how we can do that. If you pass in a string with more than one characters, then an error will throw. It should just be one length 1. And we can also go the other way with the CHR syntax to map a ASCII value to a character. So this might seem a little low level, why are we dealing with ASCII characters here? But there is a really interesting string mechanic we can use in some very commonly asked coding interview questions that use ORD and CHR strategically in order to conserve space. And what does that mean? We'll talk about that now. So here is an example of something called counting characters in a string. So let's say we want to count the number of characters in a string, assuming that the string is all lowercase or all uppercase or something like that. So that, even though it sounds like a bold assumption, it's a very common assumption that string coding interview questions will have. You can always ask your interviewer, hey, can I assume the string is all lowercase? I've done that in interviews. I've gotten string questions where I ask that and they're like, yeah, you can assume it's all lowercase. But yeah, what's going on here? So here we have this string called Python is awesome. So what we're going to do is we're going to count the number of characters in the string using an array or a list. And what we're going to do is you're going to see this line up here, char underscore counts is 0 times 26. That initializes a array of size 26 where every number is 0. So instead we could use list comprehension to do 0 for underscore in range 26. But this is a shorter way of doing it. So what we're going to do is we have an array of size 26, and I'm going to say array and list as one. They're both the same thing. I mean the same thing from both of these. But you're going to have this array of 26 to represent every letter in the alphabet, and we're going to increment the index that the alphabet character would be at every time we see that character. So A would map to 0, B would map to 1, C would map to 2, D would map to 3, Z would map to 25 in this character counts array. So when we look at this for loop, we see that for C and S, if C is space, we're going to ignore it just because we can ignore spaces. But okay, what is this going on here after? You see I equals ORD of C minus ORD of quotation A. So here we're using the fact that we can map characters to integers to get index I by getting the ASCII value of C and the ASCII value of A and subtracting them to get an index. So what does that mean? So let's say C, the character C is A. Let's say we start with the character A. So if we do ORD A minus ORD A, that'll give us 0 because both of them will be 97. So it'll be 97 minus 97, which is 0. Let's say we get B. For B, it would be ORD B minus ORD A, which would be 98 minus 97, which is 1. So you can see we have a very elegant mapping of strings to indices in an array. And why is this useful? It's useful for counting characters in O of 1 space. So for those of you who know what big O time complexity is, like basically we're using constant space to count characters in an array. And instead we can use some kind of map to map characters to their counts. But if we want like the best case time and space complexity, then we can use an array instead, so that we don't have to worry about like collision handling in maps, which some of you might learn in CSE 100 or CSE 12. There's some overhead with using maps where like if you try to map different elements, there might be collisions. Whereas here in an array, every character has its own index, so there's never going to be any collisions. So this would be like a best case time and space complexity kind of thing we can use. So given that, let's do a question called valid anagram on LeakCode. So this is going to take directly this idea and using it in this problem. So this problem is actually asked in a lot of tech company interviews. I know a couple of people who's got this for their Amazon interviews specifically. I know Shirley up here got this for Amazon. I know a couple other people who did. This is a very commonly asked question in technical interviews. So we're gonna solve this using this approach along with some other things. So let's have a look at this problem. This time I will delete my code. So you might not have that interface here, but all right. So what is this problem saying? Given two strings, S and T, return true if T is an anagram of S and false otherwise. So some of you might not have heard the word anagram since you're in like elementary school. So what is an anagram? An anagram is, or two strings are anagrams if they have the same number of letters in them. So in the example one, we see anagram and nagaram are anagrams because they both have 3 A's, they both have 1 N, they both have 1 G, they both have 1 R, they both have 1 M. So it's true. Rat and car are not anagrams because rat has a T and car doesn't. And car has a C and rat doesn't. Right? So any questions on what an anagram is? Here. No? Okay, cool. So for constraints, we know that they can be very long string, but we know that S and T consists of lowercase English characters. So given that, let's take 8 to 10 minutes to code this ourselves. So I'm not going to go over this question. I'll go over it after we code, but I want you all to have a chance to like get to implement this yourselves. And we're going to use the strategy we went over with using ORD to determine if two anagrams are, or if two strings are anagrams. So one thing to note before I let you all code, remember we're returning a Boolean, so a true or false. So we want to have some kind of like comparison that's happening. And remember, like I said, we want to use some kind of character counting because anagrams are directly related to character counts. So let's take about 8 to 10 minutes. I think we'll come back at 6:20 and try to design and write an algorithm in Python that can implement this solution. And if you've already done this problem in like any other language, try to do this in Python. If you want to refer to the slides, this is why I recommended having the slides up so that you can look at this example or other examples where we're like iterating through strings. But yeah, let's come back at 6:20 to go over this problem. If anyone has questions, like feel free to raise your hand. What's up?
It's just a master. You want to
What?
only reason I'm here. I saw them like do the tapping.
Oh my god, you should be in there coding. You're really coding right now. Yeah.
They
Wait,
cannot tell us apart.
which interview? Ooh, nice, nice. True. See the. Ooh. Oh.
No, just
True, so true.
just the go field.
Yeah. Hey, thanks for coming, by the way. I think. Yeah.
You should have read it. You should have read it.
Yeah. Oh. Huh? Yeah. I think, like we did. Like already. Yeah. 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 Ooh, so you wouldn't be able to do that necessarily. What you could do if you want to go through both at the same time is you for I in range length of S and um use the index to get T as well. Because like one interesting thing you know is if these strings are not the same length, you already know that they're not anagrams, right? So you can assume that they're both the same length. So if you iterate using I, like for I in range length of S, then you can use like S of I and T of I as well, like to do that.
And then would that, I guess that would be like
Yeah, so both of those would be like the same big O time complexity. I'd say like whatever it feels easier for you, like conceptually, you would do. If that means one loop or two loops, then that's your call. But one is not necessarily beneficial over the other because they're both the same like big O time complexity. If that makes sense. Yeah. Also, one thing to note is you can assume that these are all lowercase, so you don't need to worry about spaces. In my example, I had spaces, but yeah, you don't need to worry about spaces here. Yeah, definitely. So that's good that you're like, yeah, that's something you would clarify. Yeah, for sure. Okay, so we have like 3 minutes left for this question. What I want you all to do is if you have someone next to you, feel free to explain your approach to them and try to code this together. So like take what you already have, maybe like bounce off ideas with the person at your table, and that we'll do that for the last 3 minutes, and then we'll go over the question. Yeah. Ooh, you get hired by Amazon twice now. Crazy. True. They're like all Java. It's like crazy. All right, so it's 6:20. I know some of you might not have fully written the algorithm yet. That's okay, as long as you're getting practice writing the actual code and like thinking about algorithms, that's good. You can always go back to this problem later and implement it fully, but I'd love to hear some ideas you all had on how to solve this problem. So we have two strings, S and T. We want to see if they're anagrams or not. Does anyone have like general ideas on how we want to solve this? I'll go with Connor. Yeah, what's up? Interesting. So that does work. Yes. So his idea is let's ignore character counts. Let's just have these two strings and let's sort these strings and see if they're the same. So this is actually a one-line solution in Python. So literally what this is return sorted of S equals sorted of T. And we can run that. And we can run it. And this will work. Yes. So this is why Python is very cool. Because let's say you get this interview at Amazon, you're interviewing for Amazon, you write the one line and you're hired. So yeah, you just got in. Yeah. So yes, that's a very good approach, Connor. But let's try using character counts instead, because the time complexity of this would be a little higher because we're sorting. So it would be like on the order of n log n versus ideally O of n. So any other approaches? This is a very good one, very clever. But yes, William. Oh my goodness. Okay, I guess I'm writing one-line solutions all day. But yeah, so Python has a built-in library called collections, and we can basically get all the counts using like collections.counter of S. But we're not going to do that because let's do it like the real like hardcore way of like character counts. Anyone solve it with like character counts, like using loops and anything like that? Yes? No? Yeah, which is interesting because this time complexity is still higher than the time complexity of the counter approach, or like the character count approach, but it does run faster, which is very interesting. Like I'm not too sure, like because time complexity wise, you want to aim for the best time complexity in interviews. There might be some like discrepancy with like LeakCode's system that runs the code that might see this as faster because it's less lines or because it does some internal like optimizations or stuff like that. But the general idea for this approach is going to be like, okay, we can get the character counts of the two strings. So let's get the character counts of these two strings and let's check if they're equal at the end. And if they're equal, then it's an anagram. If it's not equal, it's not an anagram. So there's a bunch of ways to do this. Like the most, I guess, simple way is, let's say we have like counts of S as 0 times 26. We have counts of T equals 0 times 26. What we could do is for C and S, get the index as ord of C minus ord of A. Set counts of S of I plus equal to 1. Right? And then do literally the exact same for T. So I can just copy this, paste this, change this to T. And then down here, return counts of S. Yes, thank you, Nishant. Counts of S equals counts of T. So hopefully this makes sense, but the idea is like we get the character counts of each string, and then we return if they're equal. I do want to point out one optimization we can make here. I kind of heard it going around as an idea, but I think there's actually a couple. So one, we can basically, if the two strings have different lengths, we know that they're not anagrams, because they must be the same length in order to have the same character count. So that if they don't have the same length, then they can't have the same character count. So you can immediately just return in the first like statement, like if length of s is not length of t, then return, like return false. And then we can just use one loop, iterating through the indices of both. So you could do, for example, you could do for I in range length of s, and use like s of I and t of I to get the indices. Like you can get like c equals s of I, and you can get like, or we could do like cs and ct. This is not good variable naming. You should probably not do this. We could do like character of s, like character of t, and then add those to the arrays. Alternatively, we can only use one array and increment the count if we're going through string s, and decrement the count if we're going through string t, and check if all the counts are 0 at the end. So that would probably be like the most optimized way, where you have only one loop and one array, and you're just using the diff in the array. But anything with character counts is the quote unquote optimal solution, because you're iterating through each string exactly once and not doing any sorting. So yeah, cool, good work. Okay, so I did have another question. This was going to be a LeakCode medium, so we were going to do it together. I know it's already like really late, so I'm not really sure if I should go over this or not. But basically, I'll go over the idea, I guess, and then we'll leave the implementation to you all to figure out. But I did want to go over this one question because it is basically, I don't know why it's Java, but we'll go to Python. Oh, it's because I literally did it. Okay, I could just go over this code actually. But let's ignore the code for now, but let's look at the question. So this is a medium question called group anagrams. And this is also a very commonly asked question in interviews. But the idea is, okay, given an array, let's group the anagrams together. So let's say we have a list of strings. We're going to take all the anagrams that strings have with each other, group them together into lists, and then return that list at the end. So here they explain what an anagram is. But here you can see, for example, one, we have eat, t, tan, ate, nat, bat. We're going to group them together. So bat is, there's no other anagrams with bat. Here we have nat and tan, which are anagrams, and we have ate, eat, t as anagrams. That's almost a sentence. Okay, ate, eat, t, yeah. But here we have like quotes, empty quotes, AA. But yeah, like here's a slightly more complicated problem that still uses the same idea that we went over for grouping for anagrams. But here we're using more intricate Python stuff with maps and with tuples. So I'm going to go over this code really quickly. We'll try to finish by like 6:30. I'm going to change this to 26. But we're just going to go over this code just so that you gain exposure with seeing Python code that's more complicated. I found like for me, the way I prepared for interviews was basically looking at other people doing more complicated problems and seeing how different things are being used. So like, I know there's like Sunday LeakCode sessions that go on. Like if you normally go to the easy ones, or if you haven't gone at all, like maybe consider like visiting the medium ones and seeing what happens, or like going to the easy ones if you've never been before. But that's a good way to gain high amounts of exposure to like common algorithms. So here, what we're going to do is we're going to have a map of groups, right? The basic idea is we're basically going to group anagrams together. So how we're going to group anagrams together is by getting the character count. So this is the exact same thing that what we went over, right? So like for every string in our list of strings, and then for every character in S, we're going to get the character counts. This is exactly what we did in the last problem, right? It looks the exact same. And then what we're going to do here is what I talked about earlier with tuples. So with tuples, you can use them as dictionary keys. So we're going to basically convert our character count array, like our array of counts, into a tuple, and then say, okay, if not character count hash in groups, I'm going to set it as empty, and then I'm going to add the string into that group. So basically, we're going to create a new group if we haven't already seen it, and then add the string to that group. And all strings that are anagrams will be in the same group. And then at the end, then we're going to do some fancy list comprehension and return all the elements that are values in groups. So this might be a little complicated to look at first, but let's look at what groups prints when we run this. So here, it's very really kind of complicated here. It's like there's a lot of output, but you can see there's a giant tuple of character counts, right? And it maps to, and it maps to eat, t, and 8, right? So we have this tuple where 3 of those words have the same tuple. We're gonna have that be a list. Here we're gonna have another tuple with tan and nat, and then lastly we're gonna have a tuple bat. So that's going to be how we kind of approach this problem. And that's like the solution to this problem. I recommend you all go through this. Like if you have time, go through the slides again, or like you don't need to go through the slides again, but try out this problem because it uses the very same thing we went over last problem, and just using hash maps and tuples, which are going to be very commonly used in interviews. Like not necessarily tuples, but mainly hash maps. Yeah. So that's kind of how that works. Okay, so that's basically it. I just want to highlight some takeaways here. What I want you to get out of this workshop is understanding that coding interviews not only assess your coding and data structure and algorithm skills, but they also assess your problem solving and communication skills. And we want to basically pick a programming language that allows us to demonstrate that to the fullest. And we recommend Python, and people will generally recommend Python as one of the languages for doing that, due to its simplicity and like features set. And that map strings and lists are the most commonly used data structures in these interviews, and Python makes it pretty intuitive to use those. So go Python, go us. Thanks for coming, everyone. I appreciate y'all for coming. If you have some time, please fill out this exit form. We appreciate your feedback in our ACM events. And yeah, thanks for coming.